Hey, we're here at GoToMath.com. Let's click the calculus button and go down to the first derivative test. And we want to see 7-2. That's what we want to see. So go ahead, write that down, and we'll head over to the whiteboard. Alright, and we'll head over to the whiteboard here. If I can get one to come up, there we go. I'm going to go ahead and get that out of radical form and write that in exponential form. So we have h of x is equal to 4 times, I believe it was x minus 13 raised to the 1/3 power, and then plus 6. And let's make sure, okay, yeah, to 13th. So the first thing we want to do is go ahead and take the derivative. So we have h prime of x is equal to 4 times 1/3 x minus 13, and that's going to be raised to the negative 2/3, and then derivative of 6 here is going to be 0. So I'm going to go ahead and rewrite this with positive exponents. So we're left up in the numerator of 4, and then we have 3 times x minus 13 raised to the 2/3 power. So now what we want to do is take it, set it equal to 0, and of course we're looking for that critical number, or critical numbers I should say. Let me go ahead and plug c in for x. Minus 13 raised to the 2/3. Alright, so as you can see up in the numerator, there's not anything we can plug in to get 0, but down here in the denominator you can see that when c is equal to 13, you get 0 in the denominator. Now remember that this 13 must be in the domain of the original function, and it is. Okay, so now what we'll want to do is just draw a number line, at least attempt to draw one. Let's put our 13 there. We'll put our test point. 0 is always a good test point, and then of course 14 is another good test point. Why not? So then we take 0 and we plug it into the derivative, and that's going to be going in right here. So all we're concerned about is if this is a negative or a positive. So when I plug 0 in down here in the bottom, what we're going to end up with is a negative number in the denominator, and of course you have a positive in the numerator over a negative, and that just becomes negative, and I don't know what that is, but we'll just say it's negative. Okay, that's all we're concerned about. So I'm sorry, did I say negative? Where am I at? Plugging 0 in, no, that's positive. That's a positive number. I was getting ahead of myself on something, I'm not sure. Positive number, okay, that's easy, we can do that. So we know that the graph is going to be increasing. Graph is increasing, and then we plug 14 in, so h prime of 14. We know that this is also going to be a positive number, obviously, and so that's positive, and so we know that the graph is increasing. Alright, now I'm just going to kind of sketch out here what this graph kind of looks like. It's kind of like looks kind of like a crazy looking S. It's something that looks similar to this right here, where 18 is occurring about right here. So it's increasing, but it don't increase here because we can't plug 13 in the derivative, right? We'd end up getting 0 in the denominator, and then it's increasing, as you can see. And if you go to 3-3 problem, I believe it's 3-3 or 3-2, you can actually see this graphed out. Okay, what this guy looks like. I don't think there's a coefficient out in front, but anyway. So let's move over to the web page, hit the answer. Let's make sure everything's good to go on this. Right, so it's increasing from negative infinity to 13, and then we have the union symbol, means we're just joining two sets together, and then it's increasing from 13 to infinity. Alright, so it's not too bad. Okay, so you want to come on over, practice that, and I might see you there. Bye.